Okay, so Anwu, I'm making you a little video because I know that you can't be here. Um, so this is now writing your complex number in the modulus and argument form. Modulus means the length of a line, right? Like, you know, the modulus is the absolute value, and argument means the angle, okay? So if you see argument of the point x plus iy like this, it means the angle that x plus iy makes with the origin. Okay, so it's a specific angle. We are going to use, all of our angles that we're going to use are between negative pi and pi. So please make sure your angles are in that thing. So, you know, obviously pi and then negative pi, but you put them in that format. So you won't have, for example, 1.5 pi. If they give you something like this, they say find the argument of negative 4. They mean the point 0 and negative 4. So there's the point 0 and negative 4. And by argument, they mean find the angle from the horizontal to that point, which is going to obviously be pi, right? If you have the argument of the point negative 2i, that's this point down here, and you're going to have the angle from the origin to that particular point. Well, not from the origin, but from the usual starting place, which is there, to that particular point, which is going to be negative pi over 2. So the argument is referring specifically to the angle. The argument at the point 0, 0, the argument of the origin is undefined because you cannot have an angle between a point and itself, right? You are going to be writing everything in polar form. Polar form is this form over here. It is the form where you have z is equal to r cosine theta plus, I don't know why I've got a y there, excuse the y, r cosine, r sine theta, okay? You know that z is equal to x plus yi. And x, if you go and you make a triangle for your angle, and you've got the point x is equal to yi, so you've got there's x plus yi, then that is obviously going to be y, that is going to be x, that's going to be your angle. So if I go, if I want to work out the angle, I can say cosine theta is equal to adjacent over r, and now I can solve for x, so that's why I'm substituting it in there, right? And you can do the same for y. So what you end up with is you end up with z is equal to r cosine theta plus r sine theta, factorize cosine theta plus sine theta. I'm trying to rush, which is making this a little bit difficult. But this is polar form. And it makes sense. It means if you know what the angle is, so the angle is, I don't know, 60 degrees, and you go along a certain amount of distance, that's where your point's going to be, right? So any point could be described by its coordinates, which is this, or it could be described by saying we're going to go along the line a certain amount and stop, okay, at a certain angle. Here is the angle of the point minus 3 plus 3i, and that's drawn over here. So here is minus 3 plus 3i, second quadrant angle, and so our angle, you can go and use Pythagoras' theorem. If this is minus 3 and that's 3, you can use Pythagoras' theorem and you can get the value of r, which is going to be minus 2. And then the angle, you could use, the angle is obviously going to be, again, I can use tan, I can use whatever. You've got 3 over 3. And you can find your angle. So your angle is going to be a negative quarter pi, and I could have just used negative a quarter pi. There was no good reason to use to reduce the angle and make it equal to 3/4 pi, which I did. In terms of it, they're saying what is the angle? You're allowed to go between pi and negative pi, so the angle is just negative a quarter pi, which is enough. You don't need to go any further. These questions over here say convert to polar form. Polar form is very, very specific. Polar form must be positive r, must be cosine of an angle, and then sine of exactly the same angle must be plus. Okay? So if you have a minus here, that's not okay. You're going to put it into your equation. So you're going to have minus 2, minus cosine alpha, minus sine alpha, and don't forget the I. and you need to find a quadrant in which they're both negative so that you can make it into something that they're both positive and have the same angle. So that's third quadrant. Notice the reduction we use for third quadrant is alpha minus pi. If your angle is alpha and it's there, if you subtract pi, it's down here. If you say alpha plus pi, it's the same angle. But in order to get the angle between between 0 and negative pi, this is the easiest reduction to use. So please use alpha minus 180 rather than 180 degrees plus alpha, even though it gives you the same thing. So there is your angle, and it's done. Right? For the next one, it says negative 2. You can't have negative 2 in front of it, so I've changed the sign here, I've changed the sign there. And again, you need a quadrant where cosine is negative, but sine needs to stay positive. So that's second quadrant, so you're going to use pi minus alpha. Okay? And then the last one over here, we've got 2 and we've got a minus sign. We need to change this minus into a plus. So we need a quadrant where the angle will stay positive for cosine but become negative for sine, which is negative alpha. So there we go. So the principal argument, or the argument, is the angle, and you're going to be doing a bunch of reductions. If you look at this example over here, so you might want to pause the video and try them first and then look at the answers. Otherwise, you can keep watching the video. It says to you 4 plus 3i. So I've drawn the point 4 plus 3i. It says to you put it in polar form. So I'm going to work out r, Pythagoras theorem, nice and easy. And I'm going to work out the angle and put the angle in to 3 significant figures. Please don't forget your I. Next question, once you have had a chance to try it. So again, you can pause the video and try it. This angle is in the second quadrant. You can't pretend it's in the first quadrant, right? I'm saying to you that if I give it to you in the correct format, that you will be able to go square root 2 along this line, and it has to be at this particular angle. It can't be if it's there, if I go and use the acute angle, then it's a completely different point, right? So you can't use the acute angle, you have to use the third quadrant angle. So 1 plus I, third quadrant, you can work out r easily, you can work out sine alpha easily. As you know, your calculator is going to give you the acute angle, and then I've used the reduction to get me the correct angle for the second quadrant. Next bit. So there is the same idea for C. You've simply got minus 1 plus the square root of 3. So there's your point. It's in the third quadrant. You can find your value of r easily. You can find your value of alpha using cosine alpha, or using sine alpha, or using tan alpha. It doesn't really matter. And I've got that the acute angle is equal to pi over 3. And I'm in the third quadrant. So if I say pi over 3 minus pi, that will give me the third quadrant reduction, which is minus 2/3 pi. You obviously don't want to use 2/3 pi because that's second quadrant and your angle's in the third quadrant. This one's saying draw some Argand diagrams, can be a little bit confusing. It says the angle, the argument for z, the angle for z is pi over 4. So the angle is 45 degrees and z is some point between the horizontal and 45 degrees. So the theory is actually here. The idea is that if we're looking at 2 points, we know that we can work out the gradient of the 2 points. And we know that the gradient of the 2 points gives us the angle between the line that connects the 2 points and the horizontal. So the gradient of the 2 points gives you this angle here, the angle that connects the 2 points and the horizontal. So anytime we have 2 points, we can draw them relative to each other. So this one over here, they are telling you that the angle that z makes, and so that will be the angle between z and the origin, will be pi over 4 between it and the horizontal, and that makes z somewhere infinitely along that line. The second one over there, it's saying the angle between the point z and the point I, right, and the horizontal. So here's the point I, and the point z has to be somewhere along that angle, along that line. And note, you can write it like this. And it means literally the angle between the line joining the point Z and the point I, and the horizontal is pi over 4. So then you have that diagram there. Notice the open circle. You can't have an angle at that point there. There's no angle between itself and itself, right? It's undefined right there. So there's an open circle and there's undefined over there. Okay. And then the last one here is saying that the angle between Z and the point I must be between pi over 4 and 0. So in other words, you're going to shade and you should be having some sort of circular shape here, and it's between pi over 4 and 0, and that's what it's saying, right? You are then asked to write, have I left something out? I'm just looking to see if I've missed one out. No, we're over here. Then you're asked to write Z is equal to 5 plus 2I. So this is page 14. And this is A, right? And so you were supposed to find Z and the conjugate of Z and write it in polar form. So you're obviously going to find R as usual, and then you can find your angle just doing tan of alpha or sine of alpha or cosine of alpha. And obviously in the fourth quadrant, you're going to have the same thing, but you're going to have the fourth quadrant angle. Okay, then the same thing. Okay, so there's A and B on the same page. There's B, and again, negative V. So negative V is the same as V. You should know that that's a rotation of 180 degrees at this point. And again, you're going to work out your R value, work out your angle, and bear in mind that you are very much in the fourth quadrant. So you need to use fourth quadrant angle, and then the answer is there. The last one, question C, there's two methods. You're supposed to be writing it in the form x plus iy. You can just put it into the calculator. They've said to you that the modulus is 13, so that's the length of your line. They've given you the angle. You can put in your calculator and you can push equals. But if you do that, if you don't put this I in, you're going to get muddled up between which one is the x coordinate, the x point, and which one is the imaginary point. So please put the I in. You do this in the complex number mode on your calculator. Please try it without the complex number mode and then with it, and you'll see why you'll get confused if you don't put that I in. The second method, of course, is to consider a triangle where we know what the angle is. We know which quadrant it's in, we've got the R value, and of course we can solve for X or Y. It's not exactly hard, right? And then put that into the equation. Either one is fine. Last question in this booklet. Again, you should pause and see if you can do it yourself, although already this diagram is a big clue if you've glanced at it. But they are saying to you that you must find the minimum and maximum argument of Z. That means the angle that Z makes with the origin, right? And so you need the minimum and maximum value that Z can make with the origin, okay? And they tell you that the distance between Z and the point 3 plus 4i is 2. Because you see how it's got modulus things around it? It says to you, distance between Z and 3 plus 4i, right? The length of the line is equal to 2. So Z is somewhere on this circle. You can then make tangents to the circle, and then we're going to use just right angle trigonometry to work this out. So you've got this point over, here, that's 3, and that's 4, that was given. So you can find the 5 using Pythag, right? Once you've got the 5, you can then work out the size of angle alpha, right? These two are congruent triangles, it's obvious. You can work out the size of angle alpha. To work out the size of angle beta, we can work out this whole angle here, which is theta, and subtract alpha, right? So we know what the size of angle theta is because we've got that side, it's easy enough to work out, and we can subtract it. And then we can work out that the maximum angle is going to be this angle here, right? Which is 2 alphas plus beta, and the minimum angle is going to be that angle there. And you are then going to fill that in. So that's the first bit of this, and I hope that helps you.